The largest ocean on Earth is beginning to change, yet even those standing alongside its shores do not notice it. The waves offer no warning, no storm marks its arrival. The first sign is a vast band of heat stretching across the equatorial Pacific for thousands of miles. This is where the claim begins. According to scientists, the strongest El Niño in Earth's recorded history may now be forming. Scientists estimate the probability at a record-breaking 98%. If this is true, it won't be just another climate cycle. It would mean that one of the planet's most powerful natural climate engines is activating at a time when the oceans are already unusually warm. Weather systems are already unstable. Past temperature records are no longer a reliable guide. Today, we'll try to determine whether a record-breaking El Niño is truly forming in the Pacific, or whether we're witnessing an early warning signal that's being mistaken for the final event itself. To find out, we'll follow the clues left behind by the ocean itself. Buoys detecting abnormal warming along the equator. Satellites tracking the spread of a warm belt eastward toward the American continents. Weather stations recording disruptions in the Pacific's normal balance. And models showing how a single band of heat can evolve into global droughts, floods, marine die-offs, crop failures, and a chain reaction of devastating consequences across nearly every continent. But first, to make sure we're all on the same page, let's clarify what this phenomenon actually is. El Niño begins when unusually warm temperatures develop across the central and eastern tropical Pacific, while the trade winds that normally regulate this flow of heat begin to weaken. If the ocean and atmosphere start interacting with one another, this shift can alter weather patterns across much of the planet, and the first sign has already appeared. On June 9th, Australia's Bureau of Meteorology reported that conditions characteristic of El Niño were developing across the tropical Pacific. The relative Nino 3.4 index for the week ending June 7th reached plus 0.81 degrees Celsius, slightly above the Bureau's threshold. Trade winds across the tropical Pacific were weaker than average, while the 30-day Southern Oscillation Index fell to minus 21.7. At first glance, the case may seem settled. Warm water, weak winds, and negative pressure signal. The overall picture appears to be in place, but the Bureau also pointed to a missing piece that prevents a simple declaration. Cloud patterns near the international dateline have not yet shifted in a sustained way. The atmosphere has started to respond, but not completely. The missing cloud signal matters because El Niño is not simply warm water. It is a tightly coupled relationship between the ocean and the atmosphere. Under neutral conditions, trade winds push the warmest surface water westward towards Indonesia and northern Australia. Along the coast of South America, cooler water rises from below. The Bureau describes this contrast as large enough for the western tropical Pacific to become roughly 15 to 18 degrees Fahrenheit warmer than the eastern side. When the winds weaken, the Pacific's normal arrangement begins to break down. Warm water spreads eastward. The cool upwelling along the coast of South America decreases. Rainfall zones begin to shift. Pressure patterns change across the Pacific. The ocean warms the air alters the winds. Those altered winds can warm the ocean even further. This is the feedback loop scientists are watching for. Without it, the Pacific may simply experience a temporary warming episode. With it, the system can evolve into a genuine El Niño event. And if that feedback becomes strong enough and lasts long enough, the claim of the strongest in recorded history may stop being just a headline and become a measurable possibility. Speaking the National Oceanic and Atmospheric Administration, or NOAA, diagnostic discussion released May 14th, the system was placed under an El Niño watch with forecasters stating that the event was likely to develop in the near future. The probability of formation was estimated at 82% during the May to July 2026 period, with a 96% chance of persisting throughout the Northern Hemisphere winter. However, the same outlook included an important limitation. No individual intensity category exceeded a probability of 37%. This is the first major divergence in the forecast. Formation appears likely. Strength remains uncertain. NOAA also noted that the strongest El Niño events in recorded history are characterized by substantial ocean atmosphere coupling throughout the summer. In other words, surface warming alone is not enough. The Pacific must continue reinforcing itself. This creates an apparent contradiction. Columbia University and APOS International Research Institute sounded more confident in mid-May, describing the equatorial Pacific as a rapidly transitioning toward El Nino condition. Its model-based forecast estimated a 98% probability of El Nino during the May to July period, maintained that probability between 97 and 98% throughout the remainder of the forecast window. IRE also reported a signal that makes the developing event more significant: subsurface warming at depths between 160 and 500 feet. Parts of the central and eastern equatorial Pacific showed temperature anomalies reaching as much as 43 degrees Fahrenheit above average. Now, this is not merely surface heat. Itandapos, a reservoir of warmth beneath the ocean, positioned close enough to matter if winds and currents continue bringing it upward. This hidden heat is one of the reasons the strongest forecasts have not disappeared. Surface temperatures can fluctuate from week to week. Warm layer beneath the surface can continue supplying energy. If that heat rises into the upper ocean while the atmosphere continues weakening the trade winds, the event may intensify. However, if the winds recover or the feedback loop breaks down, the most extreme scenarios could fade away. Yet the disagreement between agencies does not necessarily mean disagreement about reality itself. The Andapos are studying the same Pacific Ocean using different measurement systems, different modeling approaches, and different forecast periods. That Andapos, why one forecast may sound almost certain that El Nino Andapos developing while another still refuses to make a definitive assessment of its eventual strength. IRI notes that even the data sets used to track sea surface temperatures can diverge during ENSO events. For example, OAST-V2, which is commonly used for real-time monitoring, and ERAS-TV5, which is used for official historical diagnostics, can differ by as much as 0.5 degrees Celsius, nearly 1 degree Fahrenheit. In a typical weather forecast, that may seem insignificant. But in the Nino 34 region, where thresholds are defined in increments of just a half degree, such a difference can alter how close the Pacific appears to be to a critical threshold. So the mystery is not caused by a lack of data. Etandapos, caused by the scale of the phenomenon being measured. The Pacific Ocean is not a bathtub with a single thermometer inside it. Itandapos, monitored by satellites, drifting buoys, moored instruments, ships, and statistical models that fill the gaps between direct observations. Each system captures a different piece of the Oceanandapos behavior, all while the phenomenon itself continues to evolve. Because of this, proving the phrase "the strongest ever" is far more difficult than it sounds. The historical benchmark itself is not uncertain. NOAA Andapos Oceanic Nino Index highlights the giants of the modern era. Late 1982 at approximately 2.2, late 1997 at roughly 2.4, and late 2.2 at around 2.8. Even the powerful August 24, 2023 event, which peaked near 2.1%, helped contribute to 2024 becoming the hottest year on record. Speak so if 2026 is going to challenge history at Juan Andapos, do so through a single hot week or one alarming map. It must sustain that signal season after season. The warm water must remain in place. The winds must continue weakening. The atmosphere must continue responding. Only then will an early warning signal become a record-level event. But there is another problem when comparing this event to the past. Andapos, Pacific Ocean does not exist under the same conditions as it did in 1982, 1997, or even 2000. The whole are now warmer, and that changes the meaning of the old numbers. Tropicals by the Australia Andapos Bureau of Meteorology switched to relative new indices in 2025. The goal is to separate the El Nino signal itself from the broader warming of the tropical oceans. This does not make Pacific warming any less important. It makes the question even sharper. How much of the heat belongs to El Nino, and how much belongs to a planet whose oceans already contain more energy than they once did? That is the real complexity behind the surface-level questions. A record-breaking El Nino is not simply about the Pacific becoming hot. Itapos, about the Pacific becoming unusually hot relative to a world that Tandapos already warmed. This is why this phenomenon matters even before any records are broken. Reuters reported that greenhouse gas emissions have already increased the average global temperature by approximately 1.3 degrees Celsius above pre-industrial levels. Meanwhile, the World Meteorological Organization has warned that El Nino could push global temperatures even higher and increase the risk of extreme weather events in the upcoming months. The most recent El Nino put this mechanism on full display. The WO stated that the 2023-2024 event was strong and contributed to 2024 becoming the hottest year ever recorded. The concern today is not that El Nino itself causes long-term climate change. It does not. The concern is that it can amplify a temporary surge of warming on a planet, the Tandapos, already overheated. The first global consequence is heat. This is not simply about hotter days near the Pacific Ocean, but about heat that can spread through atmospheric circulation into distant regions. Reuters reported on WMO warnings that a potentially strong event could increase the risk of droughts, heavy rainfall, and heat waves. This is where the signal from the ocean begins to move beyond the map and affect real-world infrastructure, water supply systems, power grids, agriculture, healthcare, and emergency response networks. The second consequence is the disappearance of rain. During El Nino, rainfall often shifts away from parts of the western Pacific. The Bureau describes the typical impacts on Australia as reduced rainfall across northern regions, below average precipitation, and shifts in seasonal weather patterns. This does not mean every region dries out at the same time. El Nino changes probabilities, not the exact weather, on any given day. But when seasonal rains arrive late or fail to arrive in sufficient amounts, the damage can accumulate irreversibly. Planting windows are missed. Water levels in hydroelectric reservoirs decline. Heat builds over dry land and wildfire risk increases as vegetation loses moisture. A Pacific Ocean anomaly becomes a food, water, and energy problem. Then the same system reveals the opposite side. According to the WMO, El Nino is often associated with increased rainfall in parts of South America, the southern United States, the Cape region of Africa, and Central Asia. Rain does not simply disappear from the planet. It is redistributed. Regions that lose moisture may face drought, while regions caught beneath shifted storm tracks may experience flooding. In 2024, flooding in Rio Grande do Sul, Brazil claimed more than 180 lives and displaced approximately 600,000 people. Scientists identified both climate change and El Nino as factors that intensified the rainfall responsible for the disaster. Speak. While this event is not itself a forecast for the same region in 2026, it demonstrates how strong a Pacific signal can combine with a warmer atmosphere and local weather systems, turning a seasonal shift into a large-scale catastrophe. Storms add another layer to the story. El Nino typically increases wind shear over the Atlantic, making it more difficult for some tropical storms to develop there. At the same time, warmer waters across the central and eastern Pacific can make the basin more favorable for tropical cyclones. Antonio Navarra of Italiandepos, Euro-Mediterranean Center on Climate Change, has expressed concern that warmer Pacific waters may create conditions more conducive to stronger Pacific cyclones. That is the danger of interpreting El Nino too superficially. Calmer forecasts for the Atlantic do not mean an absence of dangerous coastal storms. Wetter winter conditions do not necessarily mean beneficial rainfall. Drought signals do not eliminate the risk of localized downpours. El Nino is not a script for every storm. It is a pressure applied to the planet Tandapos's climate system, altering probabilities in ways that are predictable in principle but highly uneven in practice. Food systems often feel these unfavorable trends long before most people notice the signals coming from the ocean. Reuters reported concerns about crop yields across Asia and highlighted risk to cocoa harvest in Ecuador and West Africa. Cocoa in particular is one of the clearest examples. West Africa alone accounts for more than 2/3 of global cocoa production, while Ecuador is steadily rising among the world Andafos leading producers. If El Nino disrupts rainfall patterns or temperature conditions in both regions, the consequences will extend far beyond the farms themselves. They could spread to export ports, commodity markets, and eventually affect global chocolate prices. Chocolate represents a significant share of the confectionery sector. In the United States, it often accounts for more than half of all confectionery sales. According to the NCA, chocolate represented approximately 57% of the category in 2021. Chocolate prices may rise. So what? The point is that this is only one small example of a much larger food system that could be affected. El Niño can strike food production from multiple directions at once. Drought in one producing region, flooding in another, heat stress during flowering periods, transportation disruptions following storms, and increased disease risk after abnormal rainfall. The same chain of events can also increase disease risk. WHO Secretary General Celeste Solo warned that extreme heat may accelerate the spread of vector-borne diseases, including those carried by mosquitoes and ticks. In some places, heavy rainfall leaves behind standing water. In others, drought forces households to store water in containers. Heat can lengthen the season during which insects survive and reproduce. And then there is the ocean itself, which suffers direct damage. El Niño increases the risk of marine heat waves at a time when many coral reefs are already approaching their thermal limit. In 2024, NOAA confirmed the fourth global coral bleaching event linked to record-breaking ocean temperatures intensified by both climate change and El Niño conditions. A new, stronger event would not be affecting an untouched system. It would add further stress to ecosystems that have already shown visible signs of damage. All of these signals point toward the same unresolved mechanism, the warm reservoir beneath the equator. The International Research Institute recorded temperature anomalies at depths between 160 and 500 feet, reaching as much as 43 degrees Fahrenheit. The WMO has also observed unusually warm subsurface conditions throughout the tropical Pacific. This heat is not a final verdict, but it is the reason why the most extreme scenarios remain possible. This is where the claim and reality finally meet. The claim is that the strongest El Niño in recorded history is now forming. Speak. The reality is that the Pacific contains many of the ingredients required for a significant event, but its ultimate strength depends on sustained interaction between the ocean and the atmosphere over the coming months. Some models point toward a powerful event. Others suggest a less extreme outcome. NOAA's official intensity probabilities still do not identify a single dominant category. The world's not waiting for a single number to cross a red line. Even a moderate event arriving on a warmer planet can place already strained systems under additional pressure. For now, the ocean's surface continues to warm. The hidden reservoir of heat remains in place. The pressure signal has weakened. The trade winds are weakening. Forecasts from major agencies increasingly point toward serious consequences. Perhaps the strongest El Niño in human history is taking shape. Or perhaps the Pacific will stop just short of a historic threshold. And somewhere above this warming band of ocean, the atmosphere is deciding whether this will remain only a warning or become the climate event that helps shape the future of our planet.